Imagine holding a glass bottle in your hand. It feels smooth, clean, and almost weightless. But what if I told you that this transparent object was born from rocks, blasted by temperatures hotter than molten lava, and shaped with astonishing precision in just a few seconds? Most people never think about this, yet every window, bottle, and smartphone screen hides one of the most incredible manufacturing stories on Earth. Right now, somewhere in the world, giant furnaces burn day and night at temperatures approaching 1,600 degrees Celsius. These furnaces rarely shut down. In fact, some operate continuously for more than 15 years because cooling them would cost millions of dollars and weeks of production. Think about that for a moment. A fire so important that it never sleeps. And this is where it gets truly extraordinary. Glass looks simple, but creating it requires chemistry, mining, robotics, artificial intelligence, and engineering precision measured in fractions of a millimeter. One tiny mistake can turn a flawless sheet of glass into thousands of kilograms of waste. Yet factories produce millions of perfect pieces every single day. Today, we're following the complete journey of glass. From ancient grains of sand buried deep beneath the earth, to roaring furnaces, lightning-fast production lines, and quality tests so strict that even microscopic defects cannot escape detection. But before glass can survive fire, it must first begin its journey underground. And what happens there surprises almost everyone. Every piece of ordinary glass begins with an ingredient so common that you walk across it without noticing. Silica sand. But here's what nobody tells you. Not all sand can make glass. Desert sand looks perfect, yet its grains are too smooth and rounded. Manufacturers need high-purity silica sand containing more than 95 to 99% silicon dioxide, and only certain deposits meet that standard. Some of the world's most important silica deposits come from the United States, Australia, China, and parts of Northern Europe. Massive excavators remove thousands of tons of material every day. The sand travels through washing plants that remove clay, iron, and organic contaminants. Even tiny traces of iron can give glass an unwanted green tint, so purity matters more than most people imagine. But silica alone cannot create modern glass. Manufacturers also add soda ash, often mined from natural trona deposits in places like Wyoming in the United States. Soda ash lowers the melting temperature, reducing fuel consumption and production costs. Without it, factories would need even more extreme heat and dramatically higher energy bills. A third ingredient called limestone arrives from giant quarries around the world. This mineral helps strengthen the final glass and improves its chemical durability. Imagine millions of years of geological history being crushed, sorted, and transported so that a simple drinking glass can survive daily use in your kitchen. Then comes one of the industry's smartest secrets. Recycled glass, known as cullet. Many factories mix 20 to 80% recycled glass into every batch. Since cullet melts more easily than raw materials, it cuts energy consumption and lowers carbon emissions. What happens next surprised even experienced engineers when recycling systems first transformed the industry. Before production begins, every ingredient passes through laboratories where technicians test moisture content, particle size, and chemical purity. Computers calculate exact mixing ratios down to fractions of a percent. A large glass factory may consume more than 1,000 tons of raw materials every day. And once those ingredients enter the furnace, there is no turning back. Now the real transformation begins. Rocks, minerals, and recycled fragments are about to enter an environment so hot that solid matter turns into a glowing liquid brighter than the sunset. The question is simple. How do factories control something that looks like liquid fire? The answer lies behind the furnace doors.